PromCore is an independent platform for early stages of calculation and modeling of residential building frames, built on deep learning. Its FEMnet neural network finds the stress-strain state up to 100,000 times faster than classic FEM and processes a model of 79,332 elements in 1.1 seconds. The SmartPylon neural network arranges columns according to the plan in 0.9 seconds and synchronizes with Revit in both directions. All calculations are performed on NVIDIA GPUs, so the program spins models with tens of billions of polygons without losing frame rate. The project was developed for 8 years, 2016 to 2024, evolving from a prototype into a digital assistant to the chief designer. Today, PromCore performs static calculations in a matter of seconds, selects slab reinforcement, forms a pile field, and automates value engineering, while simultaneously deriving economic indicators. All program data is stored on your system drive C. These directories are formed after the first launch of the program. To import a DXF base into the program, you need to place the DXF file in the import folder, broken down to primitives, namely lines. The button with the image of a camera creates a screenshot of the program and saves it in the screenshots folder. The drop-down list is a selection of the working level. The levels are edited in the corresponding toolbar. The button in the form of a grid is a function that hides the display of concrete slabs, for viewing only reinforcement. In the program, the viewing camera is controlled by the W, A, S, D, R, F buttons. The pressed Shift button accelerates the movement. Double-clicking on the scroll centers the camera on the model. Importing a model from Revit. If you have a ready-made model in the Revit program, a preliminary model of the frame of a residential building, then it can be unloaded using a special plugin. All unloaded elements must be load-bearing structures. The only thing that needs to be clarified when unloading is the parameters responsible for the dimensions of the pylons/columns of the building. According to these parameters, the PromCore program will create pylons in its model. The parameter responsible for the thickness of the unloaded architectural walls is necessary for the operation of the SmartPylon neural network. We will talk about this a little later in this training video. Having selected the unloaded model of the building, save it to your disk. In the PromCore program, you can now simply load the resulting model as native to the program. If you do not work in the Revit program and also want to unload ready-made models, then there is help on the PromCore program website. With its help, you can create a simple plugin for unloading a model from your CAD or BIM program. Work with pylons is carried out through the corresponding panel. On this panel, you can specify the level of the bottom of the pylon, its dimensions, and the angle of rotation. It is also possible to work with the longitudinal and transverse reinforcement of the pylon. After calculating the building, the vertical stress in each of the pylons is specified. The minimum percentage of reinforcement determines how much reinforcement there will be in the pylon when selecting the section. The parameters, number of floors, and slab thickness are necessary to specify the section of the pylons according to the condition of pushing through the slab part. The check section function is designed to check a specific pylon. When activating the select only reinforcement function, the section of the pylons will not change. To place a pylon, Simply click on the Q button and without releasing the left mouse button, point the cursor to the location in space to place the pylon. To change the pylon parameters, select the pylon, change the required parameters, and click the Apply button. You can only change the parameters of one pylon. Work with slabs is carried out through the corresponding panel. Click the Refine Nodes button to specify the slab vertices on the plane. It is advisable to place nodes on a DWG or PNG base. After refining the slab contour vertices, just click the Enter button. Editing the slab contour is carried out by double-clicking on the object. After that, you can change the position of the slab points or delete them. It is also possible to add points by double-clicking on one of the sections of the slab contour. For the changes to take effect, you must click the Enter button. If you need to change the thickness of the slab, then after double-clicking on the slab point, you must go to the Slab Creation panel and specify the new thickness in the corresponding field and click the Enter button. Working with walls begins with the wall geometry settings. Load-bearing walls are necessary for the building frame reinforcement automation tools, such as the SmartCity neural network. Non-load-bearing walls are used for the SmartPylon neural network. The operation of these neural networks will be described in detail in this video. To place a wall, simply click the Specify Nodes button. The first click in the model space specifies the first point of the wall, and the second click specifies the second point of the wall. To cancel the wall placement function, simply press Enter. Wall reinforcement is only available when working in reinforcement automation tools. To copy elements with a large number of copies, a special function is used, which is quite common in many CAD and BIM programs. Having selected the elements for copying, we specify in the lower parameter field the required number of copies in each direction and the distances between copies. Thanks to multi-threaded processing, copying of elements is almost instantaneous. FEMnet neural network. This neural network is used only for calculating floor slabs and preliminary dynamic calculations for wind action. All calculations are performed on a video card, due to which the calculation of one floor of a building takes about 1 second. The number of floors must be specified for the analytical calculation of the building for wind action. There is no need to specify the dead weight. It is calculated automatically. The total additional load is specified as a uniformly distributed load. The user specifies the wind direction using the green joystick. Aerodynamic wind indicators are specified according to your local regulations. To begin the calculation, one floor of a residential building is required. After the calculation results will be available, namely deformations, bending moment mx and my, load areas of pylons. SmartPylon neural network. This neural network is necessary for the arrangement of pylons on the architectural floor plan. The pylons will be located strictly only inside the architectural walls. The preliminary distance between the pylons is necessary so that the neural network understands what distance to maintain between the pylons, so that the loading areas of the pylons are approximately equal. This rule helps to minimize stress in the floor slab. Permissible deviation is necessary for the neural network so that it does not suffer for a long time in search of the ideal distance between the pylons. The search takes more time, the smaller the deviation percentage. The accuracy of generation also affects the speed of pylon arrangement. On average, at least 200 iterations are needed to find several excellent options for the arrangement of pylons. On the RTX 4090 video card, one iteration for one section of a residential building takes about 1 second. During the generation of pylons, the results of the FEMnet neural network calculation are used to find more efficient pylon layout schemes. To start the generation of variants by the neural network, it is necessary to specify the location on the disk where the best 10 variants will be saved. After generating the pylon layout, 10 best options become available. Download any of the options and analyze it. The SmartCity neural network is the main tool of the PromCore program. The task of the neural network is to calculate all building structures and rationally reinforce them. This tool allows you to get preliminary costs of concrete and reinforcement for one residential building in seconds. And a couple of minutes are enough to find the material consumption for block development. As in the FEMnet neural network, the user first specifies the size of the finite elements, the loads on the floor slabs, the accuracy of the cone subtraction method. This method determines the efforts in the vertical elements. The reinforcement parameters are standards when calculating reinforced concrete structures in any calculation program, so we will not dwell on them in detail. Additional reinforcement settings allow you to form zones of different unification. The width of the reinforcement zone is the maximum width of the reinforcement zone in which the diameter of the reinforcement is determined based on the theoretical reinforcement. Let's calculate the results with several different options for the width of the reinforcement zones to see how this parameter affects the consumption of reinforcement in the slabs. After calculation, the designer can analyze the deflections of the floor slabs, bending moments, theoretical reinforcement along the lower and upper planes of the slab, as well as crack formation zones. The value at the cursor is the specific value of the stress under consideration for a specific structure, a specific building. Calculation of reinforcement and concrete volumes. After calculating and modeling the reinforcement, it becomes possible to calculate the specification of reinforcement and concrete, as well as performance indicators. Using these costs, it becomes possible to evaluate the economic indicators of the frame of a residential building. The cost of work and materials per unit is specified in the program settings. The parameter of additional weight of structural reinforcement is an additional percentage of non-main reinforcement, such as framing of holes or ends of slabs. Using this parameter, you can more accurately take into account the weight of the building reinforcement, which will be as close as possible to the reinforcement indicators during the development of detailed design solutions.